let's begin. Uh, I hope everyone pretty much has an idea about Gemma and why is it important and why the open source LLMs are coming now in much and much requirement nowadays. One of the very famous reason of that open source LLMs are competing with the cloud models is that the community of open source is very big. One and they want to develop LLMs more like the LLMs which are accessible to everyone so that we are not tied to any particular vendor. So similar like Gemma, there are many other models as well, but we are focusing on Gemma. It is one of the open source models by Google. We recently had launched Gemma 3, but for the sake of demo, we have used Gemma through Gemma 3 today. I can share you the Docker file if you want to deploy it as well. And the reason that we used Gemma 3 was simple that it was very easily deployed on Cloud Run. Gemma 4 requires the smallest model of Gemma 4 requires have much more compute and it has a slow output rate on specifically for Cloud Run. So we have used Gemma. So let's begin. Apart from the context, so let's begin. Uh, Gemma. So before we start, who am I? I am Jay Thakkar. I am the AI guy at Technology 9 Labs. It's a company in New Delhi, India. I'm also a Google developer expert in AI and cloud. Uh, Whenever you are using any LLM, open source LLM model in production, they are much more secure compared to any cloud provider. Reason that telling that they are secure is one is that you deploy it in your own VPC, you deploy it on your own cloud. Second, the entire security and entire compliances with respect to different zones is managed by you instead of a company's LLM that you are using. Uh, Second, and the reason that we have chosen Cloud Run instead of any other option is that Cloud Run is very cheap to run and very easy to deploy for this particular use case. What is Gemma? Gemma is a lightweight large language model by Google. It is cost effective for inference and it is very suitable for production workloads. But if you want to fine tune a Gemma model or Gemma related models, you can also fine tune it. There is two things that here which are not mentioned. We have in Gemma 4, we have came to something known as E2B, which is the effective bytes or uh, effective tensors or effective RAM used on a GPU. So you can, and the simple concept or translating it to simple languages, that you can use much more bigger models with much more knowledge if the effective consumption of its GPU is less. So for an example, if you use Gemma 4 E2B, so it is around 6 or 7 billion parameter of model having a size of 8 or 9 GB, but it takes around half of the GPU VRAM when it is doing the inference. So that's a new thing which has came. Uh, with these are the basic production requirements, obviously, of our daily system, that all of the models that we are using, there should be no downtime. It should be highly available across zones. If there is scaling coming into picture, it should be auto scalable. And if the requests go down, then it should also downsize itself. And apart from that, obviously, loggings and security come into picture. For this particular reasons, Cloud Run and GK are one of the best platforms available on Google Cloud. They can auto scale up to a particular amount whenever in a particular zone, and they can also scale down to zero if no requests are coming. So that's why Cloud Run we chose for this. And obvious in Cloud Run as well, you can scale down to zero, and you can also have a security features, rule-based access control, depending on the Cloud Run. You can do that, and there is also CI/CD included in in the deployment as well. CI/CD, in other words, is like you push an update to your container or you push something in the container. You technically, whenever you push it, whenever you push it, it technically rebuilds itself and gives the customers or users the latest model or the latest part of code available. Yeah, so I can share. So we will see a demo. I can show you, but before we start the demo, just give me 1 second. Yeah. So this is a 270 parameter of Gemma 3 that we have deployed, and how I deployed this using this Docker file which I am sharing you. Just 1 second. So I deployed this. I am pasting the Docker file in the. Interesting. It is taking as markdown entirely, so you can copy paste in the and create a file named as Docker file directly. And once you are done, you can just run G cloud run deploy, and it will be deploy. I can show you how I did it. Give me 1 second. Yeah. So this should be stopped, and the entire screen should be shared. Yes. Yeah. Just 1 second. Much better. So I have a folder in which I have created one Docker file. In that Docker file, the things that I pasted in the chat, it's the same file here. I have a deployed script written for me for this particular use case. So this is the command that I ran, and so I ran by a simple command. I used gcloud auth application default login, and I logged in into my gcloud CLI to my project. I changed my directory to the folder which I was currently using to deploy. Then I ran gcloud run deploy. This is the service name that I wanted to keep, and the source code, and I kept a dot like the current directory, the project in which where I wanted to deploy, and I added region is US Central 1, the port that I wanted to use to expose to the public, number of CPUs I wanted to add, and amount of memory I wanted to allot, and what is the minimum size of instances. If minimum is 0, you might sometimes face cold start. A cold start is like whenever there is no request on the CPU or on the service, it closes itself down to 0, and you don't get charged technically. And if you keep it to 1, the cold start will not happen, and cold start takes around 8 to 10 seconds depending on the size of the Docker container. For this particular thing, it will take around 8 to 15 seconds because the container will be around 300 to 500 MB. And I have also mentioned the max instances, that how many people can concurrently send request on this container. Not concurrency, number of requests can be served across the container, so maximum up to 3 containers can be spent up, and per container there can be 4 concurrency. So my current service can serve up to 12 requests concurrently, and this is the timeout. So just in case something goes wrong and user does not get a response, after 300 seconds it will get a request timeout, and the request will be failed. I have kept no CPU throttling, and I have allowed everyone to have an unauthenticated access to the particular API. Once I hit it enter, it started, and it took around 5 to 7 minutes to deploy this particular service on Cloud Run. This is the Cloud Run that has got deployed. So I'll copy this link. I can paste it in the chat if you guys want to chat. Just 1 second. And this is the collab notebook that I have created to have an inference on this. I can share you the code if you want to test it as well. That code will be as good as for the time that I'll be here. Just 1 second. Here you go. So you can oh, is larger than 1000 characters. Okay, I'll paste it into words. This is one. This is 2. This is 3. Or if you want to clone it, what I can do is, let me try that. Share, link, copy. You can open this collab, run it on your own drive, or create a clone out of it so that you can test the inference. For now, I can show you that this is the URL that I have pasted, and this is the model name that I have kept. This is the health check URL. So like whenever I said that is the API working or not, this is a health check. This is the first question, like write a haiku on cold start. Haiku is around 17 words of poem. So I asked it, so cold hands around the world strings, a silent hum, a moment lost in a chill. So this is a technical short poem which Gemma 270 million parameter has predicted. It is now I have asked like print. I have asked like what is Cloud Run and explain it in 2 sentences. So I have given it a prompt. It has given me the output is Cloud Run is a private cloud service that allows you to run applications without needing to manage infrastructure yourself. It provides a scalable, secure, and cost-effective way to deploy applications quickly and efficiently. uh, this is a third try, that third iteration of testing, which is in which I have added role is system and content you are tiers and factual. This is to give the prompt a context that you are always going to say right stuff, and then I created a function and then have added or name the three Indian stages, three Indian states. Well, technically this is wrong. These are the countries. So, yeah, APAC countries, Asia. So, name the three APAC countries. So, LLM is trying to hallucinate, and this is expected as well because this is a very small model. And I another question that I asked is which of the this is the largest by area. So Asia is technically the largest continent on on the planet. So it correctly answered the Asia. So now what I'll request to you guys is that you can open the collab and send the inference to my API and test out for like 3 to 5 minutes, and then we will resume. This is the collab URL. I think it is accessible to all. Yeah, it is accessible to all. Also, if you want to have any questions, you can shoot me a message in the chat box. I'll be happy.
Uh,
I'm not so sure why my presentation.
yeah, technical issue
Uh,
not visible.